And then we're going to utilize our pointer as possibly maybe a caulk gun, glue gun, welder, or anything. Basically, we're going to trace the top path of our aluminum piece here, or metal. So the first thing we need to do is we need to export this file to a file in which RoboGuide can run a path upon. So in Autodesk Inventor, we just go to File, Save As, Save Copy As, and then we have to switch it to a certain copy file, which we are going to use the IGES or IGS file name. So with the IGS, when you bring it into RoboGuide, it's going to ask you to do a few things. So if you don't have this setting, you have to find this setting or this save setting. So if you go to Options in Inventor, we want to make sure that number one, that we are surfaces for the output solids as. Next one, the surface type is going to be trimmed. Okay, and then the spline fit accuracy, you don't have to really worry about. Okay, but the big thing is making sure that this is surfaces and trimmed as the file output. So when I have that, then I save this. And when I go to RoboGuide, we're going to add that part. So we're going to go to the cell, add part, and we go to single CAD file. And we find the IGES file of our roller coaster and hit open. And then it's going to ask you the quality. So since we're going to be running on the surface, we're going to do high quality. Yes, it will slow down a little bit, but again, edge detection is going to be the best. So we're going to hit high quality, hit OK. So now that we have this in, I'm not going to worry about anything else in here. I'm going to hit OK. And let's add that to this table here. So let's click our table, double click it. And let's go to parts, and we're going to add our, I called it roller coaster, apply, and if it's the wrong direction, just click the edit part offset, and then you can rotate it however you want. So if you want to rotate this, say, 90 degrees, you can rotate it 90 degrees, and then you'll see the part as you would see it over on the other side. Okay, so you can easily rotate things around the axes to however you choose to, in order to get the best fit. So if I want to rotate this all the way around, I just go 180, and now I have my part rotated all the way around. So let's hit OK, and now we have our part on top here. So what we want to do now is we want to run a path in which this pointer tip, our U tool, will match the entire surface of our top of this can here. So it has to go around, up this, and be perpendicular to it the entire time, and be perpendicular and the same speed the entire time. So to program that by yourself is very, very difficult to do. So the simulation software has a program built into it called Draw Features on Parts. So in order to draw a feature on part, you need to have a part already created. So this is why we put a part in instead of a fixture and so on. So let's go to this little menu. So it should be highlighted when we have the table selected. We're going to go Draw Features on Parts. And then this is what it'll look like. Right now, everything is going to be grayed out because we have the actual table being selected. If we click the sled here, you'll notice that things are not grayed out anymore. So I click the part, and now we have the edge line, closed loop, freehand, surface fit line, and then curve. So these are the different lines you can create. So we're going to now work on this part. I'm going to start from a flat surface and work my way up. So where you click is where it's going to start. So wherever you want to start. If you want to start on the edge over here, or if you want to start up top here, or if you want to start over here, it's completely up to you. We're going to go edge line, and then I'm going to hover on this bottom surface. Now, you'll notice that depending on where your mouse is the direction. So this is the direction in which the tool is going to come in. So if I have it right here, the yellow line is the direction the tool is going to come in. So it's going to come in from the side. I want to put a bead of caulk on the top of this. So I'm going to actually hover my cursor so it's upright like this. I'm going to place it towards more in the center area. So I'm going to click, and then what I'm going to do is I'm going to start working myself around. So as soon as you go around, now this is a little tricky. You may have to click a few times. So I'm going to go up just a hair bit along this edge, click. I'm going to rotate this around, and then I'm going to continuously keep going and clicking every once in a while to make sure that if it stops. So if it stops like this, just click before it makes that mistake. and then continue moving on. You may have to rotate it around. Sometimes this takes a little while to do, but it's of course a lot faster than trying to program this freehand. Walking around all the way around that part, and you could do this majority of part. It has to have a nice clean surface to work off. If you make a mistake, just right click. Got a little click happy there, so I just right clicked and it brings you back to your previous. And then go past. So I'm going to end just a little bit close to the final portion. When you're done, just double click and it accepts. Then this will pop up and you'll be able to see the actual tool path, how it's going to run along that path. Very, very cool feature of RoboGuide simulation programming. Okay, so in here we have the general. So this is the feature name. This is what the program name it's going to call. So if you want to change it as something else, you can go along the path or caulk along a path, something along those lines. So this is using the part, the controller number 1, the grouping is going to be the robot. We're going to be using U-tool number 1 with U-frame number 1. Let's go to the raw norms, and inside here you can rotate this or you can offset this as well. So right now we're going along the edge here. If you want to move this in just a hair bit, you can offset based on these numbers. So example would be, say I don't want this to be directly upright, I want it to be angled off of here. I can hit override and blend mode, hit apply, and I can rotate along these segments. So I can go say 45 and watch what happens to our tool. It rotates 45 degrees, and then I can also do that along the ending portion. So that's 45 degrees all the way around. So that's a very, very useful tool. This is especially very useful when you get to welding. Okay, so anything that has to do with running a consistent caulk pattern or weld, this is huge. Okay. So you can change these. You can also change the translation offsets as well. We're going to go to approach and retreat. So approach would be, how does it move into this portion, and then how does it retreat off of this? So is it going to go a straight line? Is it going to use a joint method? So we can add a approach, and I can do a linear approach at a speed of 3,000. I can also add a retreat at a speed of, say, 3,000. We can change all these. We can go fine, and then this is also the offset. So right here is 100 millimeters off of our normal, which is where it's at right now. So if you want to have a nice retreat of, say, -200 for our approach, and then -200 for our retreat, we can hit apply. Okay, and then you'll see this is our retreat and approach right here. So it's going to come down to this point right here, then it's going to move in, and then it's going to rotate around this part. Okay, rotate around that part. So let's go back to the general, and let's go to generate Teach Pendant to generate all the code needed. I'm going to hit OK. I'm going to close out of our CAD to path, and here's our file, FTP or FPRG2, which is also, again, a SimPro auto-generated program. So let's go into this program. And you can see everything has been created for us. So let's check this out. Let's run this. Let's see what happens. So I run. Check out that approach. Perfect movement. This is awesome. This saves so much time and money trying to travel on complex shapes. So if you have a car door, if you have a complex weld, and you can see right now I have a limit error because of how close I am to the table. So if I change this from 45 degrees to normal, then it'll work. Or if I move the table away from here, we can modify that. So here's what I can do. And this is how easy it is to fix this. If I go back under my part here, it's called roller coaster new. If I go to that, and here's our feature. So if I double click the feature, and inside there, we're going to have feature number 1. And let's turn the cell off. We can go back to our roller coaster feature, and we can modify and regenerate the program. So say, okay, I don't need this to be 45 degrees. It could be 90 degrees. I can go back to the raw norms, and I can change these back to 0. Apply, updates the program, goes back to general, generate Teach Pendant program, runs through, and boom, automatically redoes our program, reset the faults, and let's run this. So still perpendicular. So if we wanted that 45, all we had to do is move the table away. And we don't even have to reteach things. We just have to reset up the program to reset up the points in space. But you can imagine how much time this will save with weld paths, glue paths, or even testing. And there's our retreat. So let's now modify it so our path is in the center. So we don't have to reteach all these lines. All we do is offset it inwards. So let's go to that feature segment. Double click the segment. And inside the raw norms, we're going to go to the bottom where it says translation offsets. Across the segment is the one we want. These are 2 millimeters deep. So we're going to just go 1 millimeter for the center. And you see that if it goes the wrong way, just put a negative symbol and it goes the opposite way. So now the path is down the center of our part. Go to General and then go Generate Teach Pendant. It'll update my Teach Pendant program. Hit OK, and now we have a path down the center. So now if I run this, now our tooling is directly center along that path. So a very cool feature in FANUC ROBOGUIDE.